All right, so the last lesson in Math 30-1, Binomial Theorem investigation. In this investigation, we will look at powers of a binomial where the exponent is a whole number. So, you know, binomial is like x plus y, right? What do we do with x plus y? Well, we like square it and stuff, right? We cube it. Determine the simplified form of the expansions of each of the following powers of x plus y. Note, x plus y to the fourth, which is kind of tough, and x plus y to the fifth have been expanded and simplified for you. So, what's x plus y to the 0? 1, right? Anything to the 0 is just 1. What's x plus y to the power of 1? Just x plus y. What's x plus y squared? Plus 2xy plus y squared, right? Okay, you need to do x plus y cubed. Whatever method you use to cube stuff. So you need to come up with an answer. What is x plus y quantity? Well, okay, so is that what you got? Yeah, I see all the erasers going back and forth. So maybe not. Okay, what would you do, right? Well, you take this, you just say, I need to do x plus y times x squared plus 2xy plus y squared, right? I'm cubing it, so you just multiply this by this, okay? So I got x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. And if I get that, I get x cubed, and I've got x squared y, another one, I've got 3x squared y's, and I get an xy squared, I've got 3xy squared, and I've got a y cubed, right? And that's, up until now, that's how we would do it, right? You'd square it, and then you'd cube it. And then somebody must have taken the cubed and multiplied it by x plus y to get this, and then done that. But you might start looking at these numbers and saying, these numbers, these coefficients look kind of familiar, right? 1, 2, 1, 1, 3, 3, 1, 1. Have we seen those numbers before?
Yes.
Where have we seen those numbers? Pascal's triangle. All right, so Pascal's triangle. And then we start looking at patterns, so let's look at this. Number of terms in the expansion is blank, then the exponent of the power. So to the 1 we've got, to the 2 we've got. So how does the number of terms in the expansion compare to the power?
1 more.
1 more. Is 1 more than? The expansion of x plus y to the 8th then will have how many terms? 9. In order for the expansion to have a middle term, the exponent has to be even, right? So 8 exponent, 9 terms. Middle, you need an odd number of terms, right? If I have 9 terms, then the middle is the 5th, right? 4 on either side. So the exponent has to be even. The degree of each term, so by the degree of the term, we're talking about this degree, right, is the sum of the exponents. Okay, so the degree of each term is the sum of the exponents. What is the relationship between the exponent of the binomial and the degree of each term? What's the relationship between this and the degree of each term? Or between this and the degree of this term, or the degree of this term? So what's that way to say that? It's the same as, right? It's the same. So the degree is the sum of the exponents of the variable, the relationship between the exponent of the binomial. So if it's x plus y to the 5th, each term, the degree of each term is degree 5. Okay, so they are the same. They are the same. Going from left to right, as you move from term to term, what happens to the exponent of x? So you can look anywhere here. So what happens to the exponent of x? Because, well, where does it start? And where does it end? 0. X to the 0, right? Yeah. So it starts, right, as the exponent of the binomial. So the x starts with the exponent of the binomial and goes down by 1 Okay, so starts at the exponent of the binomial. Then decreases by 1 each time. Decreases by 1 each time until it reaches 0. Reaches 0. Okay, so if we look at the fifth, it starts at 5x to the fifth, next term x to the fourth, next term x cubed, then x squared, then x to the 1, and then no x. But no x we could think of as x to the 0, right? That would just be a 1. Going left to right as you move from term to term, what happens to the exponent on the y? So what's the exponent on the y here? Y to the 0, and then, so it starts at 0 and increases by 1 until it reaches the exponent of the binomial. Okay, starts at 0, increases by 1, so starts at 0 and increases by 1 until it reaches the exponent of the binomial. Reaches of the binomial. Okay. Write the next 4 rows of Pascal's triangle as shown below. Okay, wow, so that's. Okay, do it on yours, it'll show up better.
Here. This refers to you.
It gets symmetrical after a while, right? Because we know that 7 choose 3 is the same as 7 choose 4, or 8 choose 5 is the same as 8 choose 3. So that's the next 4 rows, right? Compare Pascal's triangle to the expansion of x plus y to the n in question 1. What's the connection between Pascal's triangle and the expansion? So if we look at the expansion, we look at this. What's the connection to Pascal's triangle of this? So it's the same, it's different, it's
Similar.
okay, but what's similar? What's the same? What in Pascal's triangle is going on here?
There are numbers.
The numbers. Okay, what do we call those numbers? Not the exponent. What numbers? What do you call this number here? Coefficient. The coefficients. So 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So compare Pascal's triangle. What's the connection between Pascal's triangle and the expansion? The coefficients of the expansion are equal to the terms. Oh, sorry. Coefficients of the expansion are the values. So let's do this. The coefficients of the expansion of x plus y to the n are the same as the numbers in what row? So this is x plus y to the what? X plus y to the fifth, right? Because we know that these guys add up to these guys, right? That there are 6 terms in the 5th row. But which row of Pascal's triangle is that? rows? That's row 6. So what's the relationship? Oops. 2, 4. So the coefficients of the expansion of x plus y to the 5th are the same as the numbers in row 6. So n plus 1. The same as the numbers in row n plus 1 of Pascal's triangle. Use your new knowledge to state the coefficients of terms in the expansion, so just the coefficients in the expansion of x plus y to the 6th. Okay, well, so we know it's the numbers in the 7th row, which are above us, right? They're sitting there, so we can just write them out. And as they disappear off the screen, we write them out. So we know this is row 7. Write the expansion. Okay, so here's where the neat stuff comes in. Okay, gentlemen, now it's time to pay attention. You were okay up till now, but now you got to watch. Okay, so write the expansion of x plus y to the 6th. So you say, right, I know that that's the 7th row of Pascal's triangle, right? The coefficients are, and then here's the thing. So x plus y to the 6th. Right? So you can do this without doing what? Figuring out x plus y to the 5th, right? Which requires you to get x plus y to the 4th, which means you're going to x plus y cubed, right? And we're just multiplying by x plus y, and we're getting, if you're doing x plus y to the 6th, you're multiplying by the 5th, and that's got, 6 terms in it, and then you're getting 12 terms and having to collect like terms. We don't need to do any of that, right? We say, all right, I know it starts out as 1, so I'm not going to write the 1, x to the power of 6, plus, now I know the next coefficient is 6. I know the powers of x go down, so x to the 5th, and the powers of y go up. I know that each of these, degree of this, is equal to this number, the 6 here. Plus, and so I've got the coefficient is 15, I drop the x, and I up the y. Still adding to 6, which is this 6. Plus, I go 20, and then I drop the x and increase the y, and then a 15, and x goes down, and y goes up, and a 6, and x goes down, and y goes up, and then a 1, which I'm not going to write the 1, and the x goes down to 0, and the y. So there you go. That's x plus y to the 6th. Okay. And I don't need anything. I just need the numbers in the row of Pascal's triangle. So now you do x plus y to the 7th. Okay? Now you got numbers sitting here, right? So use those. It's already, you already did. And by now you should be saying, that's kind of neat, right? Like, because it is kind of neat, right? It's like, gee, I don't have to collect all these terms together, right? Like, the xy, if you're just doing x plus y squared, you got x squared plus xy plus yx, which we'll write as xy plus y squared. So look, I got 2 of these. Now you know how many of these you got. All right. Okay. Okay, so I just pull my coefficient out of the row in Pascal's triangle, and I just take my exponents. And as long as I'm just writing the whole thing out, right, I just count down the x's, which are going to start at this number and go down, and the y's, they'll start at 0 and they'll go up. Okay, and I just need my coefficients, which are 35. And then we've got another 35. And then 21. And then a 7. And then a 1. Okay? Cool, huh? All I gotta do is generate all Pascal's triangle.
What would x minus y to the 7th?
You could do it. You just do x plus negative y. And then your coefficient depends on, if I have negative y squared, it'll be positive if I have negative y. So this would become a negative, this would stay positive, this would go negative, this would stay positive, this would go negative, this would stay positive, this would go. Okay, well, we'll do that, right? We're going to do that because, yeah, you don't. Nobody asked you to do that. It's like, hey, what's 3a minus 2b to the fifth? But before we get there, now, that was using the rows of Pascal's triangle. But where did Pascal's triangle come from? It's like 0, choose 0, 1, choose 0, 1, choose 1, 2, choose 0, 2, choose 1, etc., right? Like that's Pascal's triangle. What's the relationship between these and the coefficients of the expansion of x plus y to the n? Same, right? Where it's n choose 0. So they are the same. Well, let's just do this. The coefficients of x plus y to the n are the same as, what am I going to say? The terms in the row. So which row? In the row. So this is 1, 5, 10, 10, 5, 1. That's what comes out in x plus y to the fifth. So what's the relationship between this n and the number here? So in the row starting with, so you're saying n plus 1 choose 0? No. N choose 0. Right? If I want the fifth row, if I want x plus y to the fifth, right, we got that somewhere. X plus y to the fifth has 1, 5, 10, 10, 5, 1. The row in Pascal's triangle that's an expansion, right, that gives you those coefficients, 5, choose 0, 5, choose 1, etc., is just that row. We'll get down to. Okay, so it just starts with n choose 0. Without looking at Pascal's triangle, explain how you could determine the coefficient of the expansion of x plus y to the 8th. So what are they? They're the terms of the row that starts with what? 8 choose 0. So they are the terms. They are the terms of the row that starts with 8 choose 0. So I want x plus y to the 8th. I just start with 8 choose 0. Write the coefficients of the expansion. So without doing the numbers, right, the coefficients are going to be 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3. Should have used bracket notation. 8 choose 8. Write the expansion, like do the actual expansion. All right, so now we don't need to have the row of Pascal's triangle. I know that if I want to expand x plus y to the 8th, it's going to look like this. So x plus y to the 8th looks like this. Now let's not do the numbers first. Let's just write out in terms of 8 choose 0. So I'm expanding x plus y to the 8th. I go 8 choose 0, x to the power of what? 8. Plus 8 choose 1, x to the, so x goes down, y goes up, plus 8 choose 2, x goes down, x to the 6th, y goes up, plus 8 choose 3, y goes up, plus 8 choose 4, plus 8 choose 5, Well, I'm going to just break smaller. Plus 8 choose 6 plus 8 choose 7 plus, I couldn't do it. You don't need to see that though, right? Because you know the pattern. So I'm just going to go, 8 choose 5, x cubed, y to the 5th, and then 8 choose 6, and I'm going to drop the power of x and increase the power of y. So if I just look at my terms, it's x to the 8th, x to the 7th, x to the 6th, to the 5th, to the 4th, to the 3rd, to the 2, to the 1, to the 0s. I'm not going to write it, just won't write it. My y value start at y to the 0, don't write it, it's a 1. Then y to the 1, y to the 2, all the way to 8, choose 8, y to the 8th. Now, we could actually write that out now, right? So 8 choose 0 is 1, so it's x to the 8th, plus 8, x to the 7th, y, plus 8 choose 2, which is 8 times 7, 28, x to the 6th, y squared, plus 8 choose 3, which, you have a calculator and can work that out, but 8 choose 3 is 8 times 7 times 6 over 5, 8 times 7 times 6 over 6, so it's 56. 56, x, drop my x, increase my y, plus 8 choose 4, I'm going to guess that's 70 because I think it is. But I gotta go look. Yeah, it's a 70, okay. I'm good now. I can do the rest. Okay, 70, x, drop my x, increase my y, and now it's symmetrical, right? It's row 8, so it's odd, it has an odd number of terms, right? It's got 9 terms, which means it has a middle. If it has a middle, then things are symmetrical about the middle, right? And 8 choose 3 is the same as 8 choose 5, right? Same value, because choosing 3 is like choosing 5. You 3 go, you 5 stay, same deal. So 56 plus 28 plus 8 plus 1. So there's the expansion, right? Useful skill. You could win bets in bars or something. I bet you I can write out x plus y to the 8th before you. No, the third term. Now, okay, where is this more useful, right? Let's look at a pattern here. So the third term in the expansion, term 1, term 2, term 3, is 8 choose 2, x to the 6th, y squared. And the 6th term, so that's term 3, term 4, term 5, term 6, is 8 choose 5, x cubed, y to the 5th. Write a similar expression. Okay, so what's the fourth term? So now we just get to, I can randomly ask you for, what's the 25th term in the x plus y to the 87th, right? And you can say, wait, I don't know how to do that. Okay. So what's the fourth term in x plus y to the 10th?
10 choose 4.
So 10 choose. Now, what's the first term? The first term is 10 choose 0. So what's the fourth term? 10 choose 3 will be the fourth term. Okay, x to the power of what?
6.
More importantly, it's like y to the power of what?
7.
So it's x to the 7th, y cubed. Okay. What's the 7th term in the expansion of x plus y to the 13th? So 13 choose, the 7th term is 13 choose 6, because the first term is 0, right? So if I want the 7th term, I go to 6. And then x to the 6, y to the 7.
So does that mean that the exponent on like x and y doesn't add up to the exponent?
Well, no, we already know that. That doesn't mean anything, right? We know the exponents have to add up to the power that you're raising
So
it
you
to.
just find the y and
Wouldn't it be x to the 7 and y to the 6?
No.
Yeah, it should be. You're thinking what? You're saying
Seventh term. So the first term is x to the 13th. Okay, 7th term will be when I reach this finger. 13, 12, 11, 10, 9, 8, 7. You're right. That's why we have fingers. And people, yeah, it's good. Take that out. I should know better. Here's the deal. This matches this. That's how, yeah. Wait, that doesn't match the pattern. You're an idiot. You can't count. Okay, you're right. Write a formula for the k plus 1th term of x plus y to the n. So it's going to be n choose 1 less, right? N choose k, the k plus 1th term, because we have no 0th term. So if I want the term that has a 0, I got to go 0 here to get the first term, right? So the k plus 1th term. And then it's x, okay, the y is to the k, and this will be n minus k. Okay, just remember these guys are the same. Okay, here's the actual, it's on your formula sheet. This is on your formula sheet. So, the binomial theorem states that the k plus 1th term, right, because k has to be 0, we have to do, 8 choose 0. In order to do 8 choose 0, we have to, we can't say the 0th term, right? So the first term is when k is a 0, right? And then the 9th term, because we go above, if it's 8, then there's 9 terms. So if you want 9, this goes to an 8. So t sub k plus 1, that term is n choose k. Okay, the n is from here. N choose k, x to the n minus k, y to the k. These have to add up to k, or sorry, to n. N minus k plus k is n. Okay, this matches this. That's just the big thing to remember, right? So the 0th term doesn't have a y. It'd be y to the 0. All right, so write the expansion of 2a minus 3b to the 4th. So you're thinking, okay, what I'm going to do is I'm going to do x plus y to the 4th. I know how to do that, right? It's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. It's 4 choose 0, x to the 4th. But here's the deal. This is not an x. This is the x. Plus y. This is the y, right? So I kind of think of this as 2a plus negative 3b, right? So the x, throw that to the 4th. So this is my x, and this is my y. Okay, because the y has to follow a plus sign, right? It's x plus y. That's the expansion. So x is now 2a. Everywhere I would have written an x, I write a 2a. Everywhere I would have written a y, I write a negative 3b. So 2a minus 3b to the 4th is equal to 4 choose 0, 2a, make sure you put it in parentheses, right? Because it's 2a that's being raised to the 4th. It's not 2a to the 4th. Don't write this. Okay, it's not that. It's the quantity 2a. Plus 4 choose 1. Yeah, so this is my x, right? So I would normally write 4 choose 0 x to the 4th. That's what I'm doing. Only when I write an x now, it looks like 2a. Plus 4 choose 1, x cubed, and when I write y, it looks like this. Plus 4 choose 2, and this is what x now looks like, but this is what y looks like. Plus 4 choose 3, and I could never fit it onto one line. Okay, so all I do is say, the binomial expansion looks like this. It's x plus y to the n. So I need to kind of rewrite this as something plus something. The first something is your x. The second something is your y. Okay, and now we can actually start to kind of work that out. So 4 choose 0 is 1. 2a to the 4th is 1 times 16a to the 4th. Plus. Okay, it's not really going to be a plus. It's going to be a minus. So, okay, I don't know. How much detail do I want here? Blah, 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 blah. Okay, yeah, we'll do more detail here. Okay, so let's do this. So it's 1 times 16a to the 4th plus 4 choose 1 is 4. 2a quantity cubed is 8a cubed, and then negative 3b. Plus 4 choose 2 is 6. 2a squared is 4a squared, right? 2a quantity squared is 4 times a squared. Negative 3b quantity squared is 9b squared. Okay, plus, and we've got 4 choose 3, which is 6. 2a. And negative 3b cubed is negative 27b cubed. Right, that's right. Negative 3b quantity cubed. Plus 1. And this is 81b to the 4th. Okay, it's positive. So it's negative 3b quantity to the 4th, right? Negative 3b times negative 3b times negative 3b times negative 3b. Okay, and now we can actually write out the whole thing. So it's 16a to the 4th minus, okay, so we got 32 times 3 is 96a cubed b plus 24 times 9, 180 and 36, 216 plus 216a squared b squared minus, okay, they're going to alternate signs, right? Because the 3b, so you were asking about, what about x minus y to the, okay, then it's x plus, and then it's negative y, quantity being, when it's even power, this thing is positive, odd power, this thing is negative. Okay, so we've got minus, where are we? Did that one. Did we do that one? Yeah, 6 times 4 times, yeah. Okay, next one. So I got 12 times 27, 324. So minus 300, you might want to check these numbers. AB cubed, and then plus 81B. Okay. Actually, I'll check the numbers with my key here, which I didn't look at before. No, that's wrong. It's 216 again. Okay. Oh, because that's a 4, not a 6. Okay, that's why it's B6. I multiplied correctly, I just had the wrong number for this 4 choose 3. Okay, so that's sort of the full expansion, right? You start with 4 choose 0, you take the first thing and raise it to the power of 4, then 4 choose 1, the first thing cubed times the second thing, and there's got to be a plus sign between the things. So, now we get this problem. This is a typical kind of problem for this expansion, right? They're not going to ask you on the diploma the expansion of x plus y to the 8th is, and give you 4 rows full of stuff, right? That makes no sense. But here's the type of problem they will ask you. If you expand 3x squared plus 1 over x to the power of 8, one of the terms will be ax to the 7th, where a belongs to the reals. Determine the value of a. So you could say, oh, it's the second term because the first term is going to have that 3x squared to the 8th. And so wait a sec, that'll be x to the 16th. So, okay, no. Right, and then I've got this 1 over x. So let's start off by thinking we want to do this. We're going to take 3x squared. So we're going to do this. In the expansion, we're going to get 8 choose k, 3x squared to the 8 minus k, and so this is plus. Let's write the 1 over x as x to the negative 1. Okay? So instead of 1 over x, I'm writing x to the negative 1 to the k. So this basically comes off the formula sheet. Right? It says t sub k plus 1, so it's some term in the expansion. Okay? We don't actually care which term. We care about the coefficient of the term that has an x to the 7th. Is, n choose k, so this is n choose k, there's your n. A to the k, I think they use an a, so this is your a. A to the n minus k, so 8 minus k, and b to the k. And we're rewriting this with that. And we say, okay, I need an x to the 7th, right? So let's strip off all, I don't care about the 3. The 3, it doesn't affect what the power of x is. So this leads to, doesn't become, but I have x squared to the 8 minus k times x to the negative 1 to the k is equal to x to the 7th. Okay, and really what I just want to know is what value of k stuck in there is going to give me an x to the 7th. I don't care about the a, I don't care about the 3, I don't care about the, x, the plus 1 over x. Right? I just want to say, if I expand this thing, one of those terms is going to have an x to the 7th. Let's figure out which term it is. Once we do that, we'll go back here, we'll plug in that value of k, and then we'll get the actual term with its coefficient, and then we'll have solved for a. Okay? But we want to let's solve a simpler problem first, right? Let's just say, what's this work out to? All right, so we say, this is x to the what? 16 minus 2k. And this is x to the what? Negative k, right? Minus k is equal to x to the 7th. Okay, how do I combine these two guys? X to the what? 16 minus 3k is x to the 7th. Okay, so now what do we say?
16 minus 3k.
Yeah, you could log both sides, but it's like, don't. When you have x to the something is x to the something different, these things are. So we know that 16 minus 3k is 7. So negative 3k is what? Negative 9. What do you know about k? You cannot get k is equal to 5 halves, right? K is a term. It's a term. So it's a natural number. So it can't be an integer. It can't be like negative 3. It's a negative third term. No, can't have that. All right, so now we know k is 3. So now we go back up here, and we use k is equal to 3, right? So we say 8 choose 3, 3x squared to the 8 minus 3, and x to the negative 1 to the 3. Okay, which is, it's going to be right, 8 choose 3, this will be 3x squared to the 5th, and then this will be like x to the negative 3. Okay, what's 8 choose 3? So it's 8 times, so it's 56, right? 56, feel free to use a calculator. What's this? So it's 3 to the 5th, 243, x to the 10th, right, power to a power. And what's this? This is just x to the negative 3. Okay, definitely use a calculator. What's 56 times 243?
13,608.
13,608? Okay, and what have I got with my x going on here? X to the 7th. That's the double check, right? If I don't end up with an x to the 7th here, then I messed up over there, right? So I said, stripping off all the stuff, I don't need the 3, I don't need the 8 choose k, I don't need this number, I don't need this number, I don't care about any of the coefficients. I want to figure out what value of k will give me x to the 7th. So we did that, right? Got k as 3. We come back up here. Now we say it's 8 choose 3. Work that all out. We get the x to the 7th. So, okay, bonus. We did get the k value right. And our answer is determine the value of a, 13,608. Okay? Questions? The next variation on this same question, which I think is the last, yeah, because then it's exercises. So the last example in the course is in the binomial, in the expansion, one of the terms is a constant term. What makes a term a constant term? So we know there's going to be x's in here, right? But one of the terms is a constant term, so
Doesn't multiply.
doesn't have an x. When don't you have an x? When you have an x to the power of 0. Okay? So, it's the same as the last question. Last question just said we want x to the 7th. What do we want? We want x to the 0. So we need to find the term. So a constant term, so you got to think, what does that mean? It means that this term has an x to the 0. Okay, so we've got 12 choose k, 2x to the 12 minus k, negative 3x to the negative 2, to the k. Make sure you're okay. Okay. Make sure you're okay, which is good if you're a pitcher. A lot of K's. Make sure that you're okay with negative 3x to the negative 2. So you're going, yeah, okay, I see it's negative, so I got to have the negative on there. 3, oh, and it's over x squared, so that's x to the negative 2 to the power of k. And then we say, I need x to the 0. I don't care, right now I don't care about this, I don't care about this, and I don't care about the negative 3. What's important to me is that I have x to the 12 minus k times x to the negative 2 to the k is equal to x to the 0. Okay? That's my preliminary solution. You could do the full thing, right? But, you know, like, why bother? Let's just figure out what k is. So this is x to the 12 minus k times x to the negative 2k is equal to x to the 0. So what's x to the 12 minus k times x to the negative 2k? 12 minus 3k, right? When you multiply powers with the same base, you add the exponents. So 12 minus 3k. So what do we know about 12 minus 3k? So what's k? No, just 4. Should I show a little more work? Let's do one more line. Negative 3k is negative 12. Look, well, okay. No, number one, as soon as you say k is negative 4, you got to slap yourself upside the head because you know that k cannot be a negative, right?
I realize.
Yeah, no, that's fine though, right? But the back check is always this. I got k as negative. No, wait, it can't be negative, right? It does not fit the terms of the solution here. Okay, so now, So now we head up here and we say, I know that when k is 4, which is what term, by the way? We're finding the 5th term, right? Okay. We don't care that it's the 5th term. But remember, this is for term t sub k plus 1, right? So we are finding the 5th term because we've got k is 4, so it's the 5th term, right? Because the first term is 12, 2, 0, and blah, blah, blah. This is the 5th term. It doesn't matter. It's not part of this. So we've got 12 choose 4, for which somebody will have to use a calculator. 2x to the 12 minus 4. And negative 3x to the negative 2 to the 4th, right? So it's 12 choose 4, 2x to the 8, and negative 3x to the negative 2. If I want, I could write that as negative 3 over x squared, right? Doesn't matter. To the 4. Okay, what's 12 choose 4? Wait, 12 times 11.
495.
How much?
495.
I would never have got there. 495. Okay, 2 to the 8th I can do. That's 256, right? So 256x to the 8th. And negative 3 to the power of 4 is 81. Positive, right? It's a negative raised to an even power. Over x to the 8th. What do the x to the 8th do? They cancel, giving you x to the power of 0. Hey, good, right? If we'd end up with an x in here, it's like, I messed up something, because I'm supposed to get an x to the 0, okay? And we legitimately got an x to the 0. So it's 495 times 256 times 81.
10,264,320.
10,264,320. So that's a very common type of question in a binomial expansion, right? Now, although we're sort of done, let's back up just a smidge. No, just not. We're not going to do anything. I'm just going to talk about something. What do I want to talk about? Not that. Okay, just what does this mean? Okay, I just want to talk about what does this mean? x plus y to the 8th, right? It means, basically think of, we're choosing x's and y's, right? So we're making arrangements of x's and y's. How many arrangements of x's are there? So there are 8. I'm going to be choosing 8 things. They could be x's or y's that I'm choosing. How many ways can I choose so that all 8 of them are x's? Just one way, right? So it's 8 choose 0. And then if you think about it, it's 8x, x, 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 x to the 8th, right? Because each of them are an x. If one of them is a y and I've got 7 x's, then I say, well, look, the y can be first, or second, or third, or fourth, or fifth, or sixth, or seventh. Okay? But any one of those is going to give me x to the 7th times y. But how many of them are there? Well, you're choosing one y. There are 8 choose 1 ways. Where is that y going to go? That's the 8 choose 1. It's first, or it's second, or it's third, or it's fourth, or it's fifth, or it's sixth, or it's seventh. If I'm choosing 2 y's, then it's first, and it's second, or it's first, and it's third, or it's first, and it's third. Well, that happens 8 choose 2 ways, right? I don't care what order they're in, but I just want to know how many ways can I put down 2 y's in a set of 8 items where 2 of them are y's and 6 of them are x's. So 8 choose 6. Now you've placed your 2 y's. Each of the ways themselves is a product of the 6 x's and the 2 y's, right? And they're not necessarily x's and y's, they're boys and girls, whatever, right? Then 8 choose 3, right? That's why this exponent is this. Okay? There are 3 y's in the group of 8 items. So there are 3 y's. They can be arranged 8 choose 3 ways. And then you've got y cubed, right? Because you got 8 things, and 5 of them are x's, and 3 of them are y's, and you multiply those together, and it gives you x to the 5th y cubed. If 3 of them are y's, then 5 of them are x's. That's why this number is the n choose k. Seriously can't choose that anymore. Right? And then you go 8 choose 4. Then you get down to 8 choose 8. So now I want them all to be y's. There's only one way to do that, right? They're each a y. And it's y to the power of 8. So that's where this thing comes into, right? It's arranging objects and how many ways can I choose 2 of the y's, and then I've got that many y's, that many x's, multiplied together gives you x to the 6th y squared. Okay. We used to do more on this in the past, but when we did probabilities and stuff. So as you go on to study further math, and you start to do probability and statistics, you're going to come back and see these again. Okay? Just so you know where you're going with this, where this goes, right? It starts to work in a new branch of math called probability, which we don't study.